Alright, so I'm going to get us started on our next little bit of tissue types here. So we've talked about epithelial tissue. One of the things I'll say about epithelial tissue relative connective tissue is that epithelial tissue, even though there's different types, they tend to be quite similar in what they're doing and how they look, where when we look at connective tissue, they are going to have certain things that they have in common, but in terms of what they look like, functions, they can be grossly different from one another. The other thing with connective tissue is it's a little bit different in that epithelium was really focused on the cells and what the cells looked like, where a lot of connective tissue, we're going to be paying a lot of attention to things that are not the cells. So things like different fiber types and the background substance that they're in that we would call the extracellular matrix. So compared to epithelial tissue, connective tissue is not particularly cellular. It is much more focused on the fiber types and the background substances that are there. So, and again, usually cells not in close contact, usually spread out with a few exceptions. What does connective tissue do? Not a surprise on this one. It connects. I mean, if we're being a smart aleck type of thing here. So, I mean, it helps hold organs in place, helps support the body either upright in terms of the bones, help support certain structures within there in terms of ligaments and other things like that. Provides physical protection to things like the brain with the skull, immune protection in terms of blood is a connective tissue. It has most of our immune cells. It is involved with the muscles and movement. So like I said, tendons are important types of connective tissue as well. In terms of storage, we can store things like calcium, fats with adipose tissue. Both are calcium with bone, both are types of storage. And again, blood being a connective tissue, it is involved with moving a large number of substances throughout the body. So you can see a lot of different functions with this. We're going to see overall that there is three main categories of connective tissue. You have what we refer to as fibrous connective tissue. Sometimes they call it connective tissue proper. We're going to kind of go through those ones first. They're pretty diverse in terms of what they can look like. Outside of that, you have supporting connective tissues. These are your different cartilages, of which there's three types, as well as bone. And then finally, we have fluid connective tissue, which is blood. And sometimes they talk about lymph being that, but lymph, it's kind of a connective tissue. It's kind of extracellular fluid that gets into lymphatic vessels. That makes it lymph. It's not particularly distinct like blood is versus interstitial fluid. Fibrous connective tissue, like I said, is the most kind of diverse type here. We can have ones that can look quite a bit different. Not surprisingly, one of the main things that ends up being important to this is the fibers of the connective tissue here. So in fibrous connective tissue or connective tissue proper, a lot of times it is the fibers that are kind of the defining characteristic here. In reality, all connective tissues, with the exception of really a couple, are really a combination of three ingredients. They have particular cell types, there's going to be a few different fiber types that can be present there, and then that background substance called ground substance or the matrix. Surprisingly, the cells are not the most abundant in this thing here. It's really a lot of times going to be the fibers or the background substance that are the most abundant substances in connective tissue. The cells we're going to see, there is a few different types of cells that we can have. We can have what are called resident cells, these cells that are always in the connective tissue. We're going to see there's a few that are kind of key to certain tissue types, things like adipose cells and adipose tissue. The other thing we're going to see is a lot of times you're going to have, based on the type of connective tissue, the name, what the cell's doing is going to be kind of similar, but because it is a different type of tissue, we give it a different name. So something like a fibroblast, it is in charge of making fibers and ground substance in kind of connective tissue proper. We call it a chondroblast in cartilage because it's making cartilage cells and fibers and ground substance. We call it an osteoblast in bone. So, but in reality, it's not the same cell, but it's doing something very similar in each of those tissue types. And again, a lot of times these cells are not in contact with one another. So to me, a couple of the key ones that you really need to know something about, fibroblasts, It actually comes from the Latin of fat making. They are not fat making cells. They are making fibers and ground substance, but these in connective tissue proper are going to be the most abundant cell. They make the fibers, which we'll talk about the different fiber types in just a second here, but it's going to be things like collagen fibers, elastic fibers, and reticular fibers. They can make any of those. Centralized nucleus in this have ends that kind of taper out on the ends here. The other one we have is adipocytes. These are sometimes referred to as fat cells as well. Main thing in this one, a little bit of cytoplasm, nucleus along the side, and a lot of lipid in a big vacuole in the center. We can also see some other stuff in here sometimes. So some of these stem cells, a lot of times we refer to as mesenchymal cells. Not going to worry about that too much. We can have some immune cells called macrophages, which are actually white blood cells that are residents of these particular areas. These fixed macrophages is what they're called. Sometimes in certain tissues they get specific names like Kupffer cells in the liver or dust cells in the lungs. But again, fixed macrophages, some immune cells there. The other thing is a lot of times we're going to have white blood cells that are going to wander through. Another name for white blood cells is leukocytes. These are immune cells that are kind of looking at these tissues again because there's a lot of space here, usually underlying epithelium. It makes sense that we have immune cells in these areas. If anything is to penetrate that epithelium, these immune cells can start responding to it in those areas. So these wandering cells are all different types of immune cells. So mast cells are very similar to what are called basophils in the bloodstream. These are cells that if there's damage to the surrounding tissue, they can release some inflammatory substances, things like heparins and histamines, that are going to draw more immune cells and more blood flow to those areas. Plasma cells are a type of blood cell called a B lymphocyte that's differentiated to this plasma cell. These are going to be the cells that produce antibodies. Again, AP2 we get into a lot more detail about these. You can have macrophages that are just kind of wandering through, very similar to those fixed macrophages, but they're ones that might be in the tissue, might not. And you may have some other white blood cells, things like neutrophils or other lymphocytes that are in there. And again, these ones I'm not as worried about. You do definitely need to know adipocytes. You need to definitely know fibroblasts. The rest of these have an understanding that you could have these either fixed or free macrophages, and some of these other white blood cells could be present there. One of the things I will say is I'm not going to make you go through and identify each one of these ones. It should be at some point here also putting up some videos just showing you the different tissue types on a slide. Might steal those from my histo class that I teach in the spring. The other thing that we'll see in connective tissue proper is these different types of fibers. You have what are called collagenous fibers, reticular fibers, and elastic fibers. Probably the most common of these ones is the collagenous fiber. Collagenous fibers, if you kind of look at the one up there, it kind of looks like a woven rope, like a braided rope. And if you think about a braided rope, so this is what I'm saying, kind of looks like a braided rope up here. You can see it's 3 layers kind of going over one another. If you think about a rope, a braided rope, or a braid for that matter, of hair, it's really strong if you pull on it from the ends. That braiding really gives it good tensile strength. Our collagen fibers in our tissues are kind of the same idea. They don't have a lot of blood flow in there. They have a white appearance when you see them in fresh tissue. Sometimes they call them white fibers. Can take on a little bit of pink. If you see a tendon or a ligament, they look very white. These are almost entirely collagenous fibers. But a good thing about this is that tensile strength. If you pull on it from the ends, and we have a lot of this like underlying the tissue of the skin, if you pull on it like I'm doing with my face here, it's providing protection against that pulling force. So it's difficult to pull them apart if you're pulling on the ends of these. Reticular fibers are a very thin collagen fiber coated with these glycoproteins, usually stained with a silver stain, so they look black in slides. These, a lot of times you'll find them in lymphatic organs, kind of being what I would call the scaffolding or the framework for those cells to be there. So you can see here reticular fibers with the different cells of that particular organ, kind of using those as a structure to have the shape to this organ. Elastic fibers, I don't have a picture of one right here, but more like a coiled spring. And if you think about a spring and its structure, when you pull on a spring, if you don't overstretch it, it will go back to its original shape, kind of like a rubber band or a slinky. That's really what these elastic fibers are doing. They're very good at, like if you think about your ears have a lot of elastic fiber in them. It's actually elastic cartilage. We'll talk about that later on. But the main thing is if I bend with this ear, it will snap right back. So a lot of elastic fibers allow this to be very stretchy, get stretched out, and go back to its original shape. These tend to look more yellow when the tissue is fresh, so sometimes referred to as yellow fibers. If you look at the picture right here, we'll talk about this type of tissue in a little bit. This is loose connective tissue or areolar connective tissue. This more purple fiber right here is an elastic fiber. This pink fiber right here is actually a collagen fiber. And really the last substance that we're going to talk about that makes up all these different connective tissues is this ground substance. It's kind of the background that these cells and fibers are in. Really depends on what we're talking about in terms of what exactly it's going to look like. When we're talking about a lot of our loose connective tissues, it's mainly going to be mostly water with some dissolved substances in it. Might be a little bit more viscous like in blood. When we get to things like bone, it can be completely solid. It's calcified kind of matrix here, kind of gummy or rubbery in cartilage. But again, it's really the combination of this ground substance and those protein fibers that we call the extracellular matrix. And again, most of the connective tissues we're going to talk about are going to be some combination of cells, ground substance, and fibers. So kind of the really bad example of this, if you were to make a really bad Jell-O salad of kind of using grapes and shredded carrots, the grapes would be like the cells, the shredded carrots would be like the fibers, and that Jell-O that it's all within would be the ground substance. So it's a really nasty example of a connective tissue in that example. So really the couple other things I want to talk about here real quick is just this idea of mesenchyme. It is a type of connective tissue. It's not one I make you identify. Mesenchyme is this undifferentiated connective tissue. You get these cells that are star-shaped, they're not really differentiated in anything. All our connective tissues come from these mesenchyme. It's basically the stem cells of connective tissue. Almost all adult types of connective tissue are going to have some of these stem cells present within it, which allow it to be able to repair. The other type of connective tissue that is very specialized is this mucous connective tissue found only in the umbilical cord. I just want you to know it exists. I'm not expecting you to know all about it. And this just shows those examples here. You can see really not much to it, not a lot of things that differentiate it. Mesenchyme, just a lot of cells in space, very immature fibers in there. Mucous connective tissue, a little bit more structure to it, but again, I just want you to know that these things exist, not expecting you to be able to identify them or know where you'd find them. So what we'll start doing on the next one here is start working through some of these different types of connective tissue and move on from there.